we are going to start with another day of the course. And in today's session, we are going to start with another important concept in Python programming. The topic of discussion for today is control structures and loops for Python programming. If you remember yesterday basics, we have talked about how we declare variables in Python, how we deploy some basic operators, and what kind of initial relationships we can establish between variables that we have understood in yesterday's part. So based on what we have learned already in previous session, we'll be utilizing that knowledge to learn something new in today's session. Like the variable declarations we know, print statements we know, all those things now we will incorporate further into control structures and loops, etc. So first, let us understand what is the focus of control structures that I'm talking about. For instance, we have here the first idea, that is control structures. And in a very simplified manner, we call them conditional statements in any programming language. We call them conditional statements. As the name indicates here, conditional statement name indicates that we are going to test some conditions in our program, and based on those conditions, certain decisions we can make further. So those conditional statements are generally divided into two main categories. We have if-else conditions. These are the most basic type of conditions we can have, if-else conditions. And then we have some derived versions of these conditions further that we'll be discussing. As a beginner, initially you can understand that if condition is the main conditional statement you can have. Like in general English language or in our day-to-day communication, we test many such conditions in our practical life. For instance, at your work or maybe at your home, you may plan many things based on the availability. Taking a very general example, we may say if it is raining outside, I'll not go for a walk. That can be a single condition that in general life you may have. If it is raining outside, I'll not go for the walk. So you are first testing a condition, whether there is a rain or not. That is your first condition you are testing. And then based on that, you are making a decision that, okay, I'll go for the walk or not. Similarly, at your work premises, you may test many conditions every day. Like the most common for the medical health professionals may be about patient vitals. When you are testing reports of the patients, sometimes you may find deviations or deranged values from the normal ranges that are specified for their vitals. And based on that, you decide whether the person is suffering from such and such disease or not. So when we have to test those conditions in a software directly, instead of applying manual procedures on that, because you can observe that in your day-to-day life, there may be 10, 20 different patient vitals that you may have to observe for making certain decision about patient treatment sometime. So manually, if you try to observe each one of those values, it may take time to make decision about patient vitals and the treatment procedures. But if all those values can be directly inserted into a software, the clerical staff, if they can directly put those values into a software, and then based on that, your software can quickly tell you whether the person is affected or not, and it can also suggest you what treatment is suitable based on the deranged patient vitals. So that will be a quick decision. Just your clerk or anyone in your office, in your clinic, can enter all the values from the report, and a quick decision can be made, and immediately with the treatment you can proceed further. So these kind of things we can make with conditional statements easily. So today our focus will be first with the conditional statements, and after learning this, we'll be moving to the loops. The second part that we'll be discussing in today's session. So that will be, we call them loops. This is another interesting thing to know in any programming language. For instance, when you have some repeated tasks to do, any repeated task that you may need to do. For instance, it could be like, for instance, if we are talking about some patient visits that we have to organize it every day, maybe for 10 days, patient has to come every day and we have to put their patient vitals every day into our record. So that can be a kind of loop, means repeatedly some task we are doing. Similarly, we may have to check patient temperature maybe thrice a day or 5 times a day based on their ongoing condition. So that is also a repeated task. And you may have to insert those values into your system based on the hourly monitoring that you are doing for the patient. So that could be like maybe one reading per hour or maybe one reading per 3 hour. So that kind of loop conditions you may execute several times. So maybe there could be some softwares that generate a quick alert for your caretakers, for the nurses, that you have to check patient temperature at such time, and they will also ask for the value. Like maybe every 2 hour or every 3 hour, the software will automatically create an alarm on the bedside of the patient, and from there they will quickly get an idea. The nurses will get the quick idea about, like, okay, I'll explain loops again. Loops we are using when there is a repeated task to do, when you have to test something time and again. So at that time, we will use loop conditions. For instance, I was explaining that maybe you have to check patient vitals per hour, or maybe thrice a day or 4 times a day, depending upon their conditions. So we can create a software setup that is installed on their bedside, or maybe that is available with the nurses or the caretakers, and it generates a auto reminder every 1 hour or every 2 hour based on the requirement. So it will just create maybe some beep sound on their software, on their bedside monitoring unit, and it will ask for the current temperature of the patient if you are monitoring temperature, for instance. So that alert system and temperature monitoring, the value entry, everything will be automated in that case. So the nurse or the caretaker can immediately check temperature. They can put that into that loop sequence. And for the entire day or for entire week, those values will be entered time to time. And all the data will be automatically sent to the doctors, or maybe for the evaluation purpose, it will be stored in an Excel sheet automatically. When those kind of repeated tasks are to be done, we can use loops for that. So in today's session, we'll consider the basics of these loops and conditional statements. We'll not develop a high-end application right now, because we are considering the basics first. Like, all of you first need to understand how these things work. So we will first understand the concept only, and with time in coming days, I'll show you how we can deploy such softwares with some basic examples also, considering this is a fundamental course. So based on that, what essential things you need to know about both these control structures and loops, we'll be discussing that further. So let me first quickly know in the chat box if this theoretical discussion is fine and you have understood the concept of both these things. Then we will move to the practical implementation. I would expect some quick updates in the chat box if we are good up to this. Okay, great. Thank you very much for letting me know. And if there are still any doubts, I'll be explaining everything time and again while implementing it. So you will get more clarity with time also. So for instance, now we will go to Google Colab. And I suppose all of you know now how we can open Google Colab. So I'll just search for Google Colab over here. And you can open up this official platform. And you just have to open a new file on this after login. I hope all of you have your logins ready now on your system. So we will just go to new notebook in Drive as we do every day. And it will open up a new sheet on which I can start working. Make sure you rename your new sheet for another day lecture. It is even possible to use previous day sheet, but for better documentation of your entire course, it is better to use separate sheets so that for later referral, you can easily find those sheet by session-wise details. So I'm putting here day 5, AI for healthcare. I'm writing here as my sheet name. And starting with the very first, that is your conditional statements. In conditional statements, we will have first basic if statement. We'll start with basic if statement at very first instance. For instance, I'm declaring certain variable here. I'm giving it a name variable 1. If you remember in yesterday's session, I have told you several ways to declare variable. And if you remember, we have also discussed that we cannot put a number in the beginning while declaring a variable. We cannot put in the beginning, but anywhere after your alphabet it is possible. So variable 1 I'm declaring, for example, here. And the value of variable 1 I'm making 0. Now I'll try to test condition of this variable here. How we apply if condition, that is the first important thing to learn. Let me just show you quickly. When you deploy these conditional statements or loops, etc., there are some fundamental concepts in programming or syntax that you need to learn. For instance, I'm applying a if condition. Then after this, at this position, you have to write the condition that you are planning to test. At this position, we can write them within brackets or without brackets. If you are writing within brackets, you have to use round brackets. Otherwise, you can use without bracket also. So multiple ways I'll be showing further. After writing the condition to test, you have to apply colons here. Observe this very carefully how I'm writing. If then whatever condition you are testing, that condition you will be passing, then you have to apply colons. And when you apply enter after these colons, your cursor will be at this position. Observe what I'm saying. Your cursor will not be at this position, which is the same level as that of your previous line. Rather, it will be at this position, slightly ahead of the normal position. This thing is known as indentation in Python. We call it indentation. Intended block or indentation. This slightly far ahead block that you will get. So inside this now, you can write any of your statements that you want to execute, like maybe print. Okay, so that will be printed inside. Any syntax or any range of syntaxes that belong to your condition, that will be written at slightly ahead level. I'll show you this practically how it happens now. Observe here, I have written if condition and I'm testing this variable. In Python, whenever we have declared certain variable with a value, Further, I'll be showing you how you can apply less than equal to that kind of symbols also. But currently the very basic one I'm using is where variable value is already given and I'm just testing value of this variable here. I'm applying colon, and then when I press enter, you can see my cursor is slightly ahead of the if statement. Otherwise, yesterday you might have seen whenever you press enter, your cursor is generally at the same level from where the previous line starts. But this time it is slightly ahead. That is due to this colon. And this is essential while working on conditional statements and loops because this defines which block has to be executed if this condition turns out to be true. And in Python, there is a rule about these conditions. If a variable has non-zero value, condition will be automatically true. And if a variable has zero value, then condition will be automatically false. So currently, this condition is, this variable value is 0, means this will be automatically false. I'll show you what difference it will make. I'm writing here a simple print statement. I'll write got a true expression. Then I'm writing one more print statement. I'll print value of variable 1 inside. And then I'm printing one more statement. First, observe the difference between them. See this point very carefully because it will be the most essential thing while writing any conditional statements or loops, etc. Once this spacing is clear, you will be able to execute anything with conditional statements easily further. That is why I'm spending more time on this. Now, these two lines, they are slightly ahead of the normal level, you can observe. Means these two are part of this condition. And it means if this condition turns out to be true, then only these two parts will be executed. However, this last print statement is outside these inner levels. You can observe this is on the same level where if condition is. It means this last statement is not the part of this if condition. Rather, it is an independent statement that is coming in flow. That means if this condition turns out to be true, this block will be executed. However, if this condition turns out to be false, this block will be skipped automatically and only this statement will be executed because this comes as a natural statement after if block. Let me know first if this point is clear. Otherwise, I'll explain these details again. Quickly let me know in the chat box if this point is clear. Okay, great. So now see, if I run this code, because I told you that this value is 0, so this should turn out to be false automatically. So if I run, it will take a little bit of time to run the first code as I told you yesterday, because it will establish connection with Google servers. And you can see it printed only this one. These two are not printed. Only this one worked because the statement is false right now. And if I put any value, like maybe 10 I'm putting, that is a non-zero value. If I'm putting a value 10, then this will be executed along with this because this is a natural statement. It will be always executed whether this block is executed or not. So now these three lines will be executed. This one is executed, this one is executed, and this last one is also executed because now the condition here turned out to be true. Now, based on what we have discussed yesterday, I'll ask a simple question. I hope all of you remember. If I ask you a simple thing that out of these three print statements, which one contains a static expression? I have discussed about static and dynamic yesterday. If anyone can recall, out of these three print statement, which one is static? Everyone can respond quickly. Don't worry, even if you are telling right, wrong, don't worry about that. I just need to make sure that you are understanding concept. And if you are getting it wrong, then I'll be here to help you. Okay, so I'm getting, yes, variable outputs I'm getting. See, what we have to do, I told you yesterday that static means when it will be printed as it is. Dynamic means when there will be change based on the variable value. So out of these three statements, this first one is static and this one is also static because they are using as it is the expression that is written within inverted commas. So one and third print, they both are static. And this is depending on variable value. So if variable value changes, accordingly, this value will be also updated. So we will call it a dynamic expression at this point. Let me know if this point is clear. I'll be also creating a link for code shared side by side so that I can share these links. Make sure you do not write anything on this link. This is a temporary link only I'll be using for this session so that I can share codes with all of you. So I'm putting this link in the chat box. You people can open it up side by side for your reference. I'll first paste this code right here so that you can all follow it if you want to execute side by side. Now I'll move forward and I'll put up one more example to help you understand this in better manner. I'm declaring here a variable I with value 20, and then I'm updating a condition I is greater than 10, and inside this I'm printing the value of I, and then I'm using one more print statement stating goodbye. First of all, you have to observe what I have written in this sequence. A very basic code again I have written. First, tell me whether if I run this code, whether if condition will turn out to be true or false. If I just run this code as it is, tell me whether if condition will turn out to be true or false. Yes, very right. Because this value of I is greater than 10. So definitely this condition will turn out to be true. And if this condition turns out to be true, let me know which one of print statements will work, whether both, whether any one of them, and if any one, which one. You need to tell me that quickly now. If condition is true, then which portion of print statement should work? Yes, very right. Of course, both will work in that case. The reason being, because this one is part of the if condition, and this one is a natural flow that we have in the code. So if this condition is true, this will be executed, and this will be executed in every case, even if the condition is false. However, if I change this value to maybe 5, observe, if I change this value to 5, in that case, tell me whether both print statements will work or any one of them, and if any one, which one will work? Yes, very right. So only last one will be working in that case because now condition will be false. So if I run this, we can see the last one only. So this is how we generally secure one specific block for the conditional statement. Like when the condition turns out to be true, then only these tasks we will be doing. Otherwise, you can compare it with your normal routine back to the example that I given you right in the beginning. Like if it is raining, I'll go to a walk. So that is just one task. After that, you have so many tasks to do in your entire day. So when you wake up in the morning, you just check your weather, you decide whether you will go for a walk or not. So that portion is done here. After that, whether it is raining or not, you have a list of work to do. So that you will go with the natural flow. So the same thing we are testing here. Wherever there are two variables to choose from, like we have two options to choose from, in those positions, we can put your if condition, and for the natural flow we can put our routine on the regular level. So this is what we are trying to learn here. Now this can help you easily in variety of vitals, as I told you, just giving you only a basic example. Like maybe if the temperature value that we have recorded 102, I'll mark it equal to, if temperature value is equal to this, and I have to pass it with certain if condition, like maybe 100.4 I consider as critical level maybe. So after this, I'll write here fever detected. So maybe certain automatic system we can make for the clinical um, areas or for hospital sites where temperature details will be automatically updated. Like we may be adding 10-20 different vitals of the patients, and every vital can be tested like this. I'm just showing you mini example only with one vital, but later on you will learn it with multiple vitals also that can be tested side by side, and you will find that with these values this is the outcome we are getting. So we can just run it quickly, and it shows that the value is greater than your threshold. We call it threshold technically. Checking threshold with this condition basically. So if the value is greater than the threshold, then we are printing on screen that fever detected. Now let us do one simple task by using the knowledge from yesterday. The task is take user input on patient temperature and apply condition for fever. Just a very simple task I'm giving you. One part will be as it is, that we have already tested, but you just have to use it with the input function that we have learned yesterday. So just to boost your confidence with the programming language, I keep on giving you these small tasks. So don't worry if you are not even able to do, but try this and let me know if you are able to create something. Share it in your chat box. And if you have any problem, I'm here to help. In the meanwhile, I'll be putting these codes also in your code share window so that you can take them for the reference. You just have to use input function this time and create similar kind of program for the task that I have marked here. Just give it a try and let me know if you can do something relevant. Otherwise, I'll guide you. Let me know if you are doing it. I cannot see any responses. Okay, yes, some of you have now inserted it here. So I can check. Looks good. So yes, seems fine. We can enter temperature value. You can make it float also because temperature values may be in float. That is a possibility. So we'll just enter temperature and then we are testing the condition and using fever detected with print. Let us check if it works fine. Invalid non-printable character. Let me just check where the error may be. Okay, it's fine. There was maybe some copy error. So you can observe here with the code that you have shared, both the codes that have been shared, they look good. So for instance, what we are doing here, maybe first thing is I'll make it float, the float values so that it can accept accordingly. So for the float values now, when I'm putting a value less than 100, you can see it says nothing. There is no response from the system. But when I put value greater than threshold, then it responds as fever detected. But practically, you may not need it like this. This is like one way decision it is making. We don't have the other part of the code. It is only one portion that, okay, if value is higher than this, then this is the outcome. So what is the status in other case, in other scenario, when the value is less than 100.4? So for that, what we use is combination of if else is required in that case. There is a need of another technique that we call combination of if else statement. Now, what does it mean when we use these if else conditions? Currently, I'm testing a condition and printing value with reference to that. But there may be some practical scenarios where you have a certain condition, then you are doing a set of work. But if this condition doesn't turn out to be true, you have another set of work to do. So for this, we need a else statement. When you have two possible ways and you want to organize them into specific blocks, like taking the same example, the basic example, if you have a condition like if it is raining outside, I'll do yoga. If it is not raining outside, I'll go for walk. So there are two things now. So you may have a condition here, rain. Something related to rain you are putting as your condition. If there is rain, then you will be testing the condition for that you will be doing yoga. So in one block, you will be putting that. If there is no rain, means the other part, the alternative part. If there is no rain, then I'll be going for a walk. So both portions you can put in your sequence in that case. So same we can do with the patient vitals also. For example, if we see patient vitals in a specific borderline area, or maybe it is deranged, it is outside our normal ranges, then we may have one plan. Like maybe if the person is having a regular fever above 100.4, we may admit him into the hospital. And otherwise, if the patient doesn't have high fever, then we will give them medicine and we will send them home. So again, you have two parts of the work. So in order to organize these two parts of the work, we organize it as if and else statement. So how this if and else work? For example, I'll take the same option from here. This one I'll take. And here I'll add a else statement. Now observe carefully. This one we are putting as first condition. This is part of if condition, means if this condition turns out to be true, then this is part of it. Then this will be executed. However, if this condition turns out to be false, then else part will be executed. So we can say like no fever. Maybe this is our second section. Just a very basic example only I'm using. And after that, there may be a normal flow of work also. So that we can always put outside. Just two branches we have inserted into if else, and after that any normal work of flow you can put in regular program sequence. So this time if I insert values, if I put value maybe lower than the threshold, then also something we are getting as an outcome, that there is no fever. So both ways when you have to test things, then you can apply it this way. I'm sharing this code in the chat box here. If you are executing it side by side, get it done and let me know if you are good with the if else condition, if you have understood its point. I'll wait for responses in the chat box. If anyone needs any explanation again, I'm here to help. They can let me know anytime in the chat box. I can guide you again. Why done is within two inverted commas? I told you yesterday that we can use them alternatively. However, this is good that you noticed. We can use it this way also. And we can use double inverted commas also, and both ways will not get any error. Although the professional way is to use single inverted comma when you have single word, and double inverted comma when you have more than one word. So that is good that you have noticed this. But otherwise, Python generally is forgiving on use of single and double inverted commas. So many times people use like similar format everywhere. But yes, this is good that you know the difference between those. Now we will move to the next step. I'm inserting here if, elif, and else, one more important combination. You can observe that the condition that I have tested here, it tests only single value, like only one threshold I'm putting, only that is being tested here. And then the alternative of that, we are checking in the else part. But sometimes there may be a scenario where you have to test multiple thresholds. Like you may have multiple conditions to test side by side. So in that case, we have a combination of if and elif statements. So what does it represent basically? Like if I try here, first I'll have a if condition. I'll test something with it, and then I'll have a block of code that will be associated with if condition. Then I'll test one more condition. So we generally prefer that we do not add if condition like this multiple times. That is not a preferred way of doing things. Rather, programmers have invented a better way to handle this. When you have to test multiple conditions at same level, what you do is, instead of if condition, they have invented one more type, that is elif condition. Here also we will put elif condition. What is this elif basically? This is else if, a combination of else if. Means this is the first condition we are testing, this is the second condition we are testing, then third condition we are testing. There can be any number of conditions that we can test, and last one there will be a else condition. Else condition will be present. Although else is always optional, but preferably there may be an alternative sequence also that practically you may need to test. And what does it represent? For example, we are trying to check maybe if a person has a BMI of this value. There may be three different conditions. Like first condition, you may say if BMI is in lower range, you may say that person is underweight. So you will be testing that condition one here. Then you may have other range, the second range, when the person is normal. So intermediate range of BMI. So that you will be testing here, the second level, and here you will be stating that person is normal. Then you may have higher range of BMI also. That may be indicating that person is overweight. And then there may be a else part also. If it goes beyond that, maybe the person is obese. So 4 conditions you may have to test. Now, it is not a straightforward point. You are not testing a single threshold, like rather multiple thresholds. So in those cases, we prefer using elif statements. So let us take a simple example for this. Maybe I'm using BMI and I'll be using it with float. And inside this, I'll use input function. Within this input function, I'll write enter patient BMI. So this is to calculate BMI value from the patient first. Now I'm applying my condition. If BMI is less than 18.5, general thresholds I'm updating here. So if BMI is less than 18.5, we will print outcome as underweight. Elif, the second condition I'll pass. You might have observed that with else condition, we cannot apply any condition to test. That is why we are using a new combination of elif that can allow you to test a threshold side by side. So I'm writing here 18.5 means if it is greater than 18.5. But there is an interesting part now. You need intermediate range. Intermediate range means you may need values maybe from 18.5 to 25, or maybe the general value we prefer medically is maybe 24.9 for the normal range. So now we need to test intermediate one. So there are different operator combinations that you can use for upper and lower boundary. Let me know if anyone can remember anything like this from yesterday's session. How you can check upper and lower boundary altogether. Any operator you remember from yesterday's session for that? Even if you don't remember, don't worry, but just give it a try. If you remember anything where I can test two conditions side by side. Yes, very right. The AND operator we have used yesterday. So I can pass here AND operator and BMI less than 24.9. So based on this, again, make sure you are applying colon, because this is the standard format of applying these conditions. And here also a intended block. This is what we call a intended block in Python. So this is also an intended block. And here I'm writing normal, for example. The commas you can use as per your choice. In my case, I'm just getting general with this. Otherwise, you can use single inverted commas. No worries in that. Now, the next one, elif BMI, we are testing maybe for 25 and maybe BMI less than 29.9. We are updating here and we are printing the value as overweight in this case. And then I have the alternative sequence, means if it goes above this, then we'll be printing obese. So I'm testing three different ranges, and above that also I'm putting in the else section now. After this, definitely you can have normal program, anything. I'm not just keeping that right now, but otherwise you will have any normal program after this that will be on the original level of indentation. Currently, we are just learning the basic concept here that we can test multiple conditions together. Now, in this case, if I try to run this code, it will just ask me for entering BMI value. And if I'm inserting maybe 34, so it says that person is obese. And I'll just run it again. I'll put some lower value, maybe 22. I'll press enter. And it says the person is normal. So just a general calculation we are doing here, and we can see that it includes multiple ranges that can be tested together. So we can deploy these kind of softwares also in the clinical practices that can assist anyone in the department to have a quick visualization over the parameters so that they can provide easy notes for doctors to sum up with their diagnosis summaries further instead of that doctors do all this thing. So maybe someone as an assistant in their department, they can assist them to handle all these values, all these ranges, and they can get a quick value on their screen for this. Else command is coming as an intent with the tab. In that case, you can just bring it back. Reason for that is, like, for instance, when I press enter after this, it will automatically come at this position. It will always come automatically at this position. So when you know that this is not part of this previous else, you just have to bring it back manually. You just have to put it here, because that is the effect of the previous column you have. Whatever you write after this, that will always come on this point. Yeah, that may be a reason I may be fast. I apologize for that. Let me know if you have any confusion in anywhere. I can help with all that. No worries in that. So now if I run any of the values, we can test it accordingly. So you just have to make sure that your indentations are on right level. Whatever is associated to a specific block, that is perfectly aligned with that only. I'll be putting this section in the code share window as well for your reference. Let me know when you all are clear up to this. I'll wait for responses in the chat box if everything is fine up to this level. Okay, great. Thank you very much, everyone, for the responses in chat box. Now I'll take it one step ahead, and here we'll be adding a few more conditions, that is nested if statements I'll be adding here. I'll insert nested if statements here in sequence. So for this condition, what we are trying to do here, one more case of the practical scenarios. When you have a series of conditions to be tested one after another, and they are related to each other only. For example, one if condition I'm placing here, and then a block of code, and then one more condition I'm testing here, one more block of code, and then one more if condition within it I'm trying to test. For example, this is the block of code. Here also another if condition, then again a block of code, and it can go to any level. Why and when you may need this kind of thing? Like when your patient symptoms are related to each other and they have a significance based on the previous test. For example, maybe I can take one condition that could be maybe, let us see, if we are checking first fever of the patient, the first condition we are checking, fever level of the patient, then we are saying that if fever is present in that person, our next question will be whether they are having cough also or not. So we are checking next condition, and if a person is having both of these things, we'll ask if they have body ache also or not. So we are testing third condition also. And if all these three are present, then maybe we will decide that the person may be suffering from certain kind of inflammation or maybe infection, etc. they may have. So that decision we will make. So when these range of conditions are related with each other, note that I'm not putting them all on the same level this time, like we have done previously. Rather, now they are associated with each other. What does it mean? Observe this very carefully now. It means this condition will be tested only if this condition turns out to be true. When this condition is true, then only this second condition will be tested, because this is on the intended level of the first block. And intended level is executed only if the previous condition is true. Similarly, this condition will be executed only if this condition turns out to be true. Means when level 2 is true, then only level 3 will be tested. So that is why they are related to each other. So sometime in life scenarios, we may have these kind of situations where multiple things are related to each other, and we are just checking their presence one after another to make decision. And I'm just giving you a basic example that as a doctor or as a clinician, sometime when patients come to you, maybe they will tell you a quick symptom that they are having fever. So then if they are having fever, first condition is true. Your next question would maybe, are you experiencing cough also or not? So maybe they will say true. Then you will ask, do you experience body ache also? So then you will be considering that, okay, these vitals are present. So I'll be using this diagnosis. So how we can deploy this kind of thing now? Let us take a simple, either you can take this kind of example, or I can use one more example over here. For instance, we are trying to decide if ICU admission is required. Based on patient vitals, we are trying to check if ICU admission is required or not. And for this, maybe we have certain criteria. Just a hypothetical condition I'm using. It is not like a very specific thing we'll have here, just a hypothetical condition. For example, I'm checking my threshold, stating that if respiratory rate is greater than 30, that is first condition. If SpO2 level is less than 90, oxygen saturation is less than 90, then again ICU admission may be required. And then SBP we are testing, systolic blood pressure we are testing, and if it is maybe less than 90, for this also we will consider it as a critical. And then final test I'm putting here, if at least two conditions are abnormal, we will say that ICU is required. Just a very basic case I'm considering. It is not like practically the same thing may be possible, but just for the understanding, a hypothetical situation we are creating. Now, what we will do is, I'm putting here first respiratory rate. You can use manual inputs also. You can use input function also. So that is your choice how you want to understand it. For example, I'm passing here the float with input function. So I'll put here input and I'll ask enter patient respiratory rate. You can use full form here also. You can update your values accordingly. Second, SpO2 level. I'll write here again float. Inside this, the input function. This will be single bracket. Here also, single bracket we may need, and I'll write here, enter patient SpO2 level. Then third value, SBP we are requiring. So I'll just use this one as it is, and I'll just replace the intermediate SBP level I'll write here. So these three entries will be taken from the patient, or maybe from their reports will be entering these values. And then I'm putting here abnormal count is equal to 0. Observe this, what we are doing here. First, I'm putting abnormal count equal to 0. It means initially we are initializing a variable that this is count 0. And based on the abnormality of these conditions, this variable we will update one by one. Observe how to do that. First, understand this sequence. Do not type side by side. First, understand this, because if you understand, I'll be sharing this code and you will be able to execute it. So try to see first how I'm organizing things here. So first thing I'm testing is if respiratory rate is greater than 30, and I'm calling it level 1, for example. Just for understanding purpose only, I'm adding these comments side by side, that on level 1 we are asking them whether they are able to have a normal respiratory rate or it is out of bound. So I'll just remove this, because after adding comment you will not be able to get the intended block. I'll add this comment after running there, or you can use tab also, that will also work fine. So I'll write here abnormal count. We are testing it. I'll be writing here plus equal to 1. Observe this very carefully. This may be slightly new way of working over variable. Maybe yesterday we have not used this type of combination. What this does, it will sum up the existing value with value 1, and whatever new value we have, that will be again stored in the same variable. Observe, there are multiple ways to use variables. One way, what we do is, maybe value of A is 10, value of B is 5, and then we are using A plus B and storing its output in C. This is one way. If you don't want a new variable, rather you want to store updated value in any of the existing variable only, there is an easier way to do this. What we can do, A is equal to, for example, we want to add A plus B and we want to store value in B again. So what we can do, A plus equal to B. This we can write simply. So what it will do, first it will do A plus B, then whatever value comes, that will be stored in A in this case. And if I do the opposite, like maybe if I change this, I'll write B and A. In that case, it will do A plus B and the value will be stored in variable B. Let me know if the meaning of this combination is clear. This is another way to use your variables together, just to save some lines of code. Like in one line, you can do the same thing sometime. You can do this with many other variable operators like minus, multiply, divide, everything you can use in this sequence. When you are multiplying two things, you can write A multiplied equal to B. So A and B value will be multiplied and result will be stored in A. I hope this is clear. So based on this, what we are doing here, I'm writing abnormal count plus equal to 1. Means initially this is 0. If I find level 1 true, then plus 1 will be added. Means abnormal count is now 1. Then I'm testing another value. SpO2 is less than 90. And if this happens, abnormal count plus equal to 1 again. Again, adding one more value into this means when this is wrong, so abnormal count is 1. If this is also wrong, then abnormal count is going to be 2, because 1 is already stored from here. So 1 plus 1 now will be 2. So now it will be testing third level. That is, maybe we are having another value of 90 again. So abnormal count plus equal to 1 again. Another value will be updated. I'll be adding double equal to here. Observe this. Double equal to, okay, this we generally need with less than value. That will be fine. So we had these three conditions with less than values. So the same I'm using here. So now three abnormal counts we have updated. And based on this, I'm passing one more condition further. Now we are expanding our program based on whatever testings we want to do altogether. Now, if abnormal count is greater than or equal to 2, another condition, this is on the normal flow. You can see this is as per the first if condition. After testing all these intermediate sequences, it will come to the normal level. And here it will check if the count is greater than 2, it will say ICU admission recommended. Else, it will print ICU, or we can maybe other condition we can have, maybe like general ward or observation. This may be the other way out to deal with the patient in that scenario. So we are just updating this entire sequence. I'll explain things again. Observe here. First, we are taking three different vitals from the patient reports, or maybe from the caregivers will be getting these values. Then I'm putting here a initial variable of abnormal count, means initially abnormal count is 0. We assume initially that no variable, no abnormality is there in patient vitals. Then we start testing level 1 test, level 2 test, and level 3 test we are doing. So if level 1 test is true, then this will turn out to be 1. If further level 2 test is also true, this will turn out to be false. If level 3 test is on, then this will also turn out to be in action, and this will turn out to be 3 value in that case. But observe one point here. Based on the organization of these conditions, if initially this condition turns out to be false, then it will not enter into any of these. If this first condition is false, then it will not enter into any one of these. That is also a, we can say, disadvantage in some case, but we organize conditions based on the requirement only. This is just a sample only we are using. Later on, you can create high level conditions also, where everything you will be testing based on the requirement. But it is important to understand the fact, you have to understand that if first condition turns out to be true, because these are part of the first condition. So if first is false, then of course this will not be executed. And if this is not executed, means this is also not executed. And if this is not executed, means this is also not working. So in this way, we can check different values in sequence. So I'll run this. I'll insert values one by one. It will just ask relevant values. And it says ICU admission is recommended because this one also surpassed and this one is also greater than the threshold. Only this one was less. So based on this values, we can say that ICU admissions are recommended. So a general test for testing multiple patient vitals. In this way, we can create and we can set up a algorithm in practical. We can have this kind of software maybe on mobile app, on computer, where all these values can be entered all together, and it will quickly tell whether any emergency patient need ICU treatment or general ward treatment. Observe this code and let me know if this is clear. If anyone is experiencing any trouble, I'm here to help. Please let me know. Take some time and then let me know in the chat box if everything is fine. I'll wait for responses in the chat box. I hope everyone is connected and are able to work. If there are any troubles, let me know, I can help. I cannot see any responses in the chat box, so I'll just presume that everything is fine on the other side, because not even the queries I can see in the chat box. Thank you very much for your quick update. Now I'll introduce loops slightly. We have discussed the reason for using loops, and there are generally two different loops that we prefer to use, while and for loop, and how we use them, that we'll be learning further. First, I'm starting with while loop, for example. So in this case, I'll be setting up a simple value. For example, count is equal to 0, I'm making, while this count is less than 7, a condition I'm putting here. With while loop also, we can put up a condition. We can test that condition. And as long as that condition is true, certain set of commands we can execute. So I'm testing here that while count is less than 7, the writing style is same. You need these columns here, and after that you need indentation for the inner block of a while loop. So I'll write here print the count is equal to count. So this is your static text. This is the dynamic text that we'll be getting from the count value. And here I'm updating count is equal to count plus 1 every time. And then I'm just printing done over here. Just a simple sequence I'm creating. Observe what we have here. First, I'm testing whether the value of count is less than 7 or not. Then we are printing that value one by one. And every time in this loop, we are just increasing the value of count. Means first time it will be tested. So this will be 0 less than 7. So this condition will turn out to be true. So it will print the count is 0. And then it will make 0 plus 1. So new value of count will be 1 in that case. Then it will go back to this condition here, because it will stay within the loop. It will stay within the loop as long as this condition is true. So now this time it will test 1 is less than 7. So again, condition will turn out to be true. So now the count is 1 that will be printed. And then 1 plus 1, the count value will be 2. So again, that will be tested and it will go up to 6. When it is 7, when the count value is 7, at that time, this condition will turn out to be false. So at that time, this portion will not be executed, only this portion will be executed. So now if I run this, you can observe the same pattern. It started with 0 to 6 because I'm saying less than 7 is condition. So up to 6 only is less than 7. After that, it will not execute. So it will come out of your loop statement and that will be executed. So as long as this condition is true, your code will stay within the loop. Let me know if you are able to understand this. I'm putting this code in the code share window also side by side. Get it done and let me know if this is clear. Thank you for the update. I hope others are also able to get it. Now, this loop condition, while loop, we can use as it is as a single while loop, and we can also combine it with else condition. For example, in this case, we are only talking about the state that is less than 7, but we are not talking about any alternative state that we have seen in the if-else conditions previously. So here also that portion is possible. Like maybe I'll copy this same thing and I'll insert it here while with else technique we are learning. And here I'm inserting the same code, but with a else statement. And here I'll write the count is not less than 7. So maybe an alternative thing we are printing here. The count is not less than 7 because we are testing it for the 7. So for that, I can put a else part, and inside this, I can print this thing. You can do any other calculations also. There may be any number of lines or blocks associated to while or else. We are just creating basic programs, so I'm using just minimal possible lines here. So if I run this part, now you can see it will go from 0 to 6. Then it will say the count is not less than 7 and then done. In the previous case, it was just going up to 6 and then done. So if any alternative thing is to be done, we can put that in the else part. And this again is a general statement that is coming in your normal program flow. So whenever this while and else are done working, after that, this print statement will work here. Observe the difference in comparison to your if-else conditions. In case of if-else, else was an alternative state, and it has to be executed only when your if condition is not working. Observe that. In case of if-else, when we have tested if and else conditions, in that case, if was your main condition, else was alternative. So in case when if turns out to be false, then only else is executed. However, in case of loops, if you have while with else, both of them will be always executed. There is no alternative thing. Both of them will be always executed. But the only difference is that first, the while loop task will be done. Any number of cycles it can have, 10 cycles, 100 cycles, 1000 cycles, any number of cycles it can have. And when those cycles are over, then else part will be executed. So else is not an alternative statement here. It will be always executed. But the cases when your program comes out of while part, then only it will be executed. Let me know if this use of while else together is clear. Okay, great. I hope others are also good with it. One more type of loop we have is for loop. This is also widely used in any of the programming languages. While loop and for loops are commonly preferred. So in this case, for the for loop, you don't have a direct condition, but you have a range of things over which you are evaluating something. For example, I'm writing here x in range of 6. I'm introducing one more function here, default function, that is range function. And what does it do if I'm using a range function somewhere? What is the purpose of it? There are thousands or lakhs of different functions in Python. Just few of them we are using as per learning curve. So currently I'm using a range function, and this can have so many formats. Like one basic format it can have is the end value. The end value we insert here, like maybe I'm inserting end value 10. So this range, if there is only one value inserted, this will always start from 0 up to 1 less than last value. So it will be up to 9. So it will be 0 to 9 in that case. The range function will start from 0 up to 1 less than the given value. There are other formats of range functions also that you may learn later on. Like we can write it with range 0, 10. So in that case, it will start from 0, end at 10, or precisely this may be preferred when you have some other options like starting from 2 to 8. So it will start from 2, it will go up to 7. The end value will always be 1 less than the given value. Start value will be used as it is. When single value is given, that is considered only end value. When two values are given, one of them is start value, one of them is end value. So for this, I'm using a range function here. And I'm saying that for a range of 6, means 0 to 5, it will consider, we will print the value of x. What we are doing here is, we are checking x variable in the range of 6. So x will get variable value 0, 1, 2, 3, 4, 5, 1 by 1. 1 by 1, we are printing that value. And then I'm going to the else part. And here I'm writing finally finished, for example, just any random statement I'm updating here. So the alternative statement, else optional you can use, otherwise in some cases only for you may use, like we have done in the while case also. Sometime only while is needed, sometime while and else combination is needed. Same goes with the for loop also. Sometime only for is needed, sometime for and else combination may be needed. So I'll run this part and you can see 0, 1, 2, 3, 4, 5. We are printing the values of x one by one. When we are coming out of this loop, means when value is greater than 5, so we are coming to the else portion in that case and we are executing that part. So for loop is generally for a range of values that you may have. This can be used in a variety of different ways also. We can see that further with many examples. But the basic version only I have told you right now. Try this. Try to observe the comparison between whatever we have studied till now. And then let me know if this is clear. Then we will do some practice examples on all these things that we have learned today so that you can have a better understanding on the topic. Observe all the parts and let me know when you are ready. I'll wait for a few more responses if it is going fine with others as well. Let us do a little bit of practice on whatever we have learned. Some small codes we'll try to create here. First, I'm writing here one task that we'll be doing. We'll write monitor hourly temperature data. First, the basic version of this task we will do. So what I'll write here, for R in range, maybe 1 to 7 I'm keeping it, like for maybe 7 hours we want to monitor. So 1 to 7 we are keeping it, starting and ending value. So it will be 1, 2, 3, 4, 5, and 6. Up to 6 it will go. If you need to observe it for 6 hours, we'll be writing it like this. Other way out also we have learned, that is 0. You will write range 7 only. That is also feasible. We are just learning different patterns only, nothing else. You can use it anyway. So maybe we are observing for 6 consecutive hours and we are checking hourly temperature of the patient. So I'll write here print. I'm using F function. Yesterday also we have used it. With curly brackets, we can pass the dynamic value inside. And right here, I'll give a reminder to check temperature, for example. What we are doing, currently the time factor I'm not adding. Observe that time factor I have not added because that will be the extended versions of the code that you may learn in future. Currently, we are just running a basic loop only that will continuously create like 1, 2, 3, 4, 5, 6 hours and check temperature reminders it will set up. Timer we are not using right now because that will be little advanced level for you. Like if you actually want to create a timer for every hour, that will be a different execution. Currently we are just learning use of the conditions or loops, etc., that we have seen earlier. So if we are running it like this, for every hour it will be creating a reminder, check temperature like this. So depending upon how many readings we need a day, it will be setting up your values accordingly. So if you need 10 readings a day, 5 readings a day, accordingly, it will be asking you to insert those values. Now, let us make it a little advanced. What I'll do is, along with this reminder, maybe we will ask the caretakers or maybe nurse to enter value of temperature also. So what I can do is, I'll write the same condition for R in range, maybe 1 to 7 or 1 to 5. I'm just using a general range only. And I'll ask for the temperature value every time. So I can use the input function for that. So I'll write here input. And inside this, I'll pass a static plus dynamic sequence. Observe how I'm using it. Enter measured value of temperature for R. And within this, a dynamic sequence I'm using. What is the benefit of doing this? First, let us understand. Observe, I'm using it with F technique. Yesterday, we have learned that this allows you to add any dynamic value in between your inverted commas. General, without F, this will all appear as your static text. But if I insert F before inverted commas, then it will make the curly bracket part as dynamic. That is the first learning. Now, next, when this loop will run, it will keep on printing enter measured value of temperature for R1, then enter measured value of temperature for R2, and so on. And along with this, it will ask for those values and we will print those values, for example. Maybe I'll print those values separately here. That is your choice, definitely, how you want to use. But just a simple example we are using here, that R values will be used and we will map them with the entered temperature value side by side. Observe this. This is the printing sequence for R1 respective temperature value we are printing here. Now, if I run this portion, observe here, it is asking me to enter measured value of temperature for R1. So accordingly, the caregiver may check temperature and they will enter that value. Maybe they are entering a value of 98.9, for example. I've inserted this. Then for the second hour again, it will start asking. Then the person will check value and maybe they will enter a value of 100.1. And then for the third hour, maybe 100.9 they are inserting. Then maybe for the next hour, we are updating it. So maybe 100, one they are entering, and so on, up to, depending upon how many hours we have included, it will take up the values. So in this way, in practical scenarios, these kind of conditions can be easily utilized. Try to observe this one execution. I have shared this code in the code share window also. Try to run this on your end. You can make some changes also as per requirement, and then let me know if it is clear that how we are using the combinations of dynamic and static values in between, along with the knowledge of for loop, how we are deploying here. I'll wait for responses. Take your time, observe things, and update me in the chat box. Okay, great. I look forward for responses from other participants also if everything is going fine. Okay, great. So now I'll show you one more interesting way, like when you can apply things on multiple readings. Use for loop with multiple readings in a list. Note that the concept of list we will learn in tomorrow's session. I'm just using one sample over here just for the basic introduction how things may proceed. Originally, the concept of list we'll discuss in detail tomorrow. For now, there is only one simple thing you need to understand. Consider that till now we are using all the values as single units, like only one vital value we are getting from the patients. Maybe when you are doing research and you are getting data of maybe 10, 15 patients altogether, or maybe hundreds of patients altogether, and you have to apply decision making on them. So your values may be stored in a list in that case, list of patient values like. So list we generally store within square brackets like this. And you may have maybe patient temperature levels like maybe 98, 100, 99, 101, 102. These are your patient temperature levels. So now you have a list. Based on this, maybe you have to decide which patient needs what kind of treatment. So maybe you may consider some of them as normal, some of them you may consider as observation required, and some of you these may be considered as maybe critical, etc. So you may have to rank them differently when a long list of patients is available for you. So we can use for loops and if else conditions in these scenarios. Now we are learning one next level. Till now we have done it with single value only. We will learn lists in detail tomorrow, but still just to get a glimpse of how this information may be useful for you. Like we have patient oxygen readings maybe. And this is inside list I'm writing here, maybe 89, 92, maybe 78, just some random values only I'm inserting. And these are the oxygen readings of the patients maybe. Now, first thing is I have to iterate through all these values, because one by one I'll be checking all of them. Currently, I'm just showing 5 values. You may have hundreds of such values. So instead of iterating manually through those values, you can iterate through them by using your programming technique, and with which you can directly update your for loop based iterations. So for instance, I'll write here in the next line, for value in patient oxy. This is a list. We are just iterating through. So for values in patient oxy, so it will go one by one to these values. One by one, it will go to these values. And then inside this, we are testing condition. If value is less than 90, then I'll print that value along with a statement that belong to that kind of condition. For example, I'll state this one as maybe less than 90, I'll consider maybe critical. I'm just using some uh, hypothetical thresholds. You can change them based on your domain expertise. And second, I'm using maybe 95. And I'm writing here for this particular value, maybe we want to decide that observation is needed. And then maybe third level, we can put maybe else only. If you have other conditions to test, that is your choice. Otherwise, I'll put else only. And here I'll write if value, the remaining condition, whatever, if less than this or less than this, both of these are gone, then value other than this we will consider as normal, for example, means greater than 95. If anything occurs, that will be considered as normal in that case. So we are just running this, and you can see we can easily organize each one of them. It shows that first value is 89, so this is critical value. Then next one, it says that the patient needs observation. Then again to critical values, and for last one, it states that the person is normal. So in this way, now you will be able to manipulate your data from the patient values. You can change these values. You can take this input manually also from different patients and prepare your list. And then on the back end, this kind of program may be applied automatically so that your patient data gets segregated automatically instead of requiring any manual change. Currently, I'm doing this for the display here only. Later on, we will learn that how these conditions can be directly applied on your Excel sheets. And if in one column you have values like this, you can apply a direct condition on that column, and you can create a new column that can have these kind of categorical sequences automatically based on your previous column values. So in this way, you can modify your entire CSV file or Excel file in one go, just by using your these kind of backend codes on the feature variables. So run this and let me know if the point is clear. I'll wait for responses in the chat box if everything is going fine. So based on what we have learned till now, let me give you a simple task that you can try. I'm writing here process 10 glucose readings and classify each. Almost similar kind of example what I have done here. I'm telling you the rules for conditions. First, we will be saying that if it is less than 70, we will consider it low. If the value is between 70 to maybe 180, we will consider it normal. And if the value is greater than 180, we will consider it high. So these three conditions, I have set it up: low, normal, and high for glucose readings. 10 glucose readings. So that means some kind of list you will be creating with 10 variables. They will be representing your glucose readings. And after that, you will be setting up these values for your conditional statement, and you will check the thresholds for final entries. So greater than, less than. Just check what kind of conditional statements you may have to use, how loop you may have to use, and how you may have to organize all those things just by using all the previous details that we have learned throughout the session. Try to deploy one simple code. I'll wait for a while for your responses. Take your time and let me know when you are done. Post your code in the chat box. If anyone is confused with any part, they can also let me know by putting their query in the chat box. I can assist. I can see some responses in the chat box. I hope others are also trying. I'll wait for a while for others' responses and then I'll test your codes here. Great. You people are doing a great job. Let me know if anyone else is also trying. Yes, I can see a few responses. Make sure you all check indentations. Be careful with indentations, otherwise you'll get an error in your code. So I'm just checking few random codes from the list. I'll be updating it here. And let me just remove this copy error that I may get due to some restrictions on the notebook. Okay, so this is what you have shared, one of the codes I have used from here. And we have a range of glucose values. So 10 values we have inserted. Then we are iterating through values in this glucose list. Then the first entry we have made is based on the threshold we had here, lower than 70. So that looks fine. We are saying that this is low in that case. Then we are checking the normal range. So this is also used very fine. You have used the AND operator in between, and less than greater than symbols also you have used. Looks fine. Let us run this if it works fine or not. Great. We can see all the reference values marked accordingly down here. So many of you have also shared further. Always make sure that your indentations are right, because this is the most common error. If any of your indentations are not right, for example, if I show you that this indentation is not right, you can see these error markers. And yesterday I also told you that what are the different ways to identify errors in your Python programming. So if I run this code right now, you can observe these lines here that indicates the first level of error. Then it shows that we have an error at line 5. So this is my first line, second line, which is empty, third, fourth and fifth line. Here it is showing me error. So line 5 I can identify. Then this notch I can see that error is somewhere at this position. And then clearly it is stating that this is an indentation error and it is expecting an intended block if statement is present at line 4. Means the error is about this indentation. This is how it will guide you if you do not use indentation appropriately. So after this, it will be automatically solved. So these things you always have to keep in mind. And a few more errors, like yesterday we discussed that your Python programming is case sensitive. If I use any of these like P print with capital P, you can see this error line below print. And then if I run this, I can see the error. It says at least the arrow we can find here on this line exactly it is showing that there is a problem with this, and then it is saying that name print is not defined because it cannot understand this is a by default function. So you just have to correct it, run it again, and then it will be fine. So it is not just about learning the ways to program, it is not just about knowing the syntax, but you also need to understand how to diagnose when anything is wrong in your code. You should be able to identify those wrong values. So we have updated these details right here, and we have also seen how at different levels the indentations may change. One more thing I want you all to observe that, for example, I'll add here any random expression just for some guidance over here. Like I'm inserting just some normal done statements in between. Observe here one point that for this if statement, this is the level of indentation, and for all lines associated to this block, the indentation level should be same. But it doesn't have any impact on the indentation level of next block. Observe again what I'm saying. This block is associated to this if condition, and this if it contains more than one line, they all should be on same position. They should all have same indentation level. Similarly, these set of lines are associated to this part only. So their indentation level should be same. What does it mean? If I take these lines slightly ahead, observe, I'm taking it slightly ahead. Still, we will not have any error because at least these lines, both of them are on the same level. They can be ahead of normal level, not behind the normal level. Means towards this side it is not accepted, but towards this side they can take any level, and making sure that for one level all the lines are on the same position. Like if this set of lines are at this right below your value point, at that position only we have to place, and these all I'm keeping slightly ahead, so still this is fine. This will still not give you an error. If I run it, everything is fine with it, no error. So block of code is associated with each other. They do not have impact on the previous block or on the next block, but together they should be on the same level. You will observe if I take it to this level, slightly behind, means if these two are not on the same level, you can see those error lines coming again. Means again, this is disturbed because these two belong to each other. They have to be part of same block and they should be on the same level. If I run it like this, it will say that there is an indentation error. It says that unident doesn't match any outer indentation level. Means this one is not matching with any outer indentation level before it. So this thing also you need to understand very carefully. You can position a block of code together at some other place, but all the lines for that inner block should be at same place. They should not be at different position with respect to each other. Let me know if this difference is clear. Okay, great. So I'll insert this last set of codes also into your code share window. And since we are already on the verge of session, I'll not take it any further. Rather, if we have any queries, any discussions, the house is open for all of you. Please let me know in the chat box if everything is going fine, if you are able to learn something new with this session of today, and if any queries you have, that also you can post in the chat box. I hope I'm able to help you all for learning Python programming.